Okay, so we left off, remember, on Friday talking about points, lines, and planes. We had kind of a weird discussion, talked about how none of these things really exist, but we all know what they are. We introduced the concept of an undefined term, right? So we know that a definition uses known words to describe a new word. In geometry, we talked about how there's some things that are just so basic, like point, line, and plane, that we can't even formally define them, but we all understand what they mean. And we looked at some examples of that. We defined a point as being so small that it has no dimensionality. Is she here? Okay. Okay. Has no dimensionality. We described it as how many D? How many D was a point? 0D, right? That you can't measure any width, height, or length. In Moodle, and this is kind of important after I'm done going through this slideshow, which by the way, the slideshow is now up on Moodle, so you can download this if you want to at home and look at it also. In Moodle, we would indicate point A as just capital A. That's all you need to do. Okay? A line, we talked about, remember, extending in one dimension. We called it 1D, right? It has like an extended length, for example, but it still has no thickness, so it only travels in one direction. We represent it in order to indicate that it goes forever. Obviously, we can't draw something forever, so we just draw the arrows on the end, and that means it keeps going, right? We can name a line in a variety of ways. The way that we talked about doing it was naming it based on 2 points that sit on the line. And we said something pretty important about that. How many points does it take to define a line? 2. There are an infinite number of points on the line, but it only takes 2 to completely define that one individual unique line. If I pick the points A and B, for example, there is only one possible line that can travel through those 2 points simultaneously, right? And so we name that. Here's how we did it. We name that line AB, in Moodle at least, right? We call it line AB. And what's the representation that we would write on paper for that? Remember how we'd write that? That's how we'd enter it in technology, but how would we write it on a board? Yeah, good. We had a little arrow symbol over the top. Good. So it looked like that, right? That means line AB. Now, what about this? Sometimes we'll put just a single letter down to describe a line, and usually it's going to be a script, like a cursive letter. So we could also call this line L in this case, because the L is meant to represent the whole line. Okay, that'll happen too. So there's in geometry, there's sort of multiple ways a lot of times to describe things or label things. And it just sort of depends on the context. I promise you it'll make sense which one is being referred to in the book or in a Moodle problem. As you go on, it'll really start to make sense. But until it does, don't be afraid to ask questions. Anything I missed there? No, I don't think so. This is all ringing a bell, right? Okay. All coming back. Okay. Here's our symbol. In Moodle, we represent it as lowercase L-I-N-E, and then in parentheses you put the 2 points. Or we could even put line L if there were an L next to it. A plane, we said, is how many D? Line was 1D? 2D. Okay, it has both an extended width and height maybe, but no depth, right? Plane, we looked at some examples in the room of planes. Ceiling would be like a piece of a plane. The front wall would be a piece of a plane. A lot of times, I write on a plane up here, a piece of a plane anyway. But remember that in geometry, a plane extends forever. So we're always only representing it by just a piece of the plane. How many points are required to define a plane? 3. Yeah, it takes 3. Good. And the way we write a plane, there's no real symbol for a plane like there is for a line or for a segment or something like that. So we just write it as plane ABC, or in Moodle, we'd write it as lowercase plane, and then in parentheses, we'd put the 3 points that define it. Okay? Okay, so a few basic concepts just in review. We can't define this stuff, but we understand the concept that a point lies on a line or a plane, right? Collinear points, we say, are points that are on the same line, because remember, co means same and linear means line, okay? Coplanar points, you can figure that out. Co means same, planar means plane. So those are points that lie on the same plane. Let's look at a couple examples here. Let's see. Somebody, some brave soul, tell me 3 points that are collinear. Yes, sir.
D, E, and F.
D, E, and F. Agreed? D, E, and F are collinear because we can see that they lie on a single line. Okay? Okay. Now, how about, can you name 4 points that are coplanar? What do you think? What?
H, G, E, F.
Say it again.
H, G, E, F.
H, G, E, F. Lie on the same plane?
No. It's H, G, G, E. G,
F,
E.
G.
Oh, I got you. Okay, yeah, there we go. D, E, F, G. There you go. Those do, don't they?
Yeah.
Those all lie on the yellow plane. Good. Okay, so can anybody name a different 4? We'll challenge you. Could you name a different 4? See a different 4, Dean? It's not the yellow plane. You have to kind of use your imagination just a little bit, Ruby. What do you think? Yeah, we could do that, couldn't we? We know that D, E, and F lie on the same line, right? So wouldn't we just have to find some other point that's not on that line to create a plane? Does that make sense? Well, G was the first example. G is not on D, E, and F, and so those 4 defined the yellow plane. But what if we took D, E, and F, and then some point H that's off of the yellow plane? That still works, doesn't it? It'd be really hard to draw, and as you'll come to realize, I'm artistically challenged here, but we could draw a plane. I'll just draw a triangle from that plane, how about? Here's a triangle from that plane, and if I continued it through, it would just kind of look like this, wouldn't it? Whoops, hang on. I'll make it dash so we can see that it's now behind the plane. Does that make sense? So it just maybe kind of continue on down there, but it falls behind the plane. There's where it intersects the plane, right? So if we do something like if I kind of shaded this in, there's the part we can see, and there's the part that's hidden by the yellow plane. Does that make sense? Okay. You really have to use your imagination. One thing geometry is really good at is it trains you to kind of visualize things. Turn things around in your mind. Okay, very good. So D, E, F, and H, although they're not, the plane isn't drawn, so we had to draw that. That's the plane including the purple triangle. Okay, name 3 points that are not collinear. John, what do you think? 3 points that are not collinear. Sure, G, D, E. Good, that works. Maddie, name 3 different ones.
E, G, H.
Sure, E, G, H would work too, right? Does that make sense? Okay. How about 3 different ones even? We got 3 different ones? What do you think? What do you think, Janine? You got 3 different ones even? And those? It's hard to keep track of which ones have been said, isn't it? I'll give you a hint, nobody's used the H.
H, E, H.
Sure, that works. Yeah, what do you think?
H, E, D.
A, G, D, yeah, works too. There's a whole bunch of possibilities. Last one, come on, what do you think?
G, F.
Sure, G, E, F, that works too. Good. Many possibilities. Okay, another undefined concept in geometry is that a point on a line is between 2 other points, right? And this was important. We talked about this just a little bit This in geometry, it sounds a little strange, but in geometry, we literally call this betweenness. I don't know if I have one N or two there. I think it's like that, betweenness. Maybe there's two N's, I can't remember. So what does that mean? If we want to find, for example, a point that's in between A and B on this line, what has to be true for it to be between A and B, do you suppose? What do you think? I'm going to draw an example here. You tell me yes or no, I'll call this point C. Is point C in between A and B? I mean, we might say that in non-geometry, we might say something like that, right? Like I might say, if I'm standing right here, I could maybe say something like, if I'm by the door, I could say, well, Ruby's between me and Sean, right? I mean, it's because she's kind of in the middle, right? And that would sort of make sense. But in geometry, that's not good enough. In geometry, do you suppose point C is actually between A and B?
No.
It's not. You're right. What would I have to do to point C to make it in between A and B? What do you think?
Put it on the line.
Okay, good. It's got to be on the line, and once it's on the line, it has to be. There's still another element here, isn't there? Because now we would say if C went to there, it's between, right? What if I put C here instead? What if I moved it up there? Is that in between A and B?
No.
No, it's not, is it? It's not. So how do you suppose we could tighten that up a little bit? So there's two parts to this, right? We said that in order for C to be between A and B, it's got to be on the line that includes A and B. But it has to be somewhere in here. How can we specify that, do you think? Without using the word between, because that's the word we're trying to define. It's between. Any ideas? I'm going to give you a hint. I can't remember how much we talked about this on Friday. But if I say this, if I write down AB with no symbol on top, did we talk about what that meant? We did. I don't know if we mentioned that. Did we? Doesn't sound like it. Okay, AB with no symbol on top, there's two ways you can interpret that. You can either think of it as being, one, it could be the distance between A and B. Let me erase this. This is getting in the way. Or we could alternately define it as the length of segment AB. Which we wrote like that, didn't we? Right? Okay, so now any ideas? How could we, if like AB represents the length of that segment or the distance between those points, and then we could say AC would represent the distance between A and C, and CB would represent the distance between C and B. Can you think of a way, sort of mathematically, that we could state that C has to be what we think of as being in between those endpoints, but we can't use the word between? In the middle, okay, it's in the middle, you're right. How can we say that maybe in terms of, I'm going to give you another little hint here. How could I say that in terms of these three distances? The distances AB, AC, and CB. How could I write a relationship among those three distances which tells me that C has got to be in the middle of A and B somewhere? Okay, now say that again. You're on something here.
A plus C equals B.
Okay, so not A, but how about like AC, that distance plus CB would have to equal what? AC, that makes sense, doesn't it, right? So the other thing we could say, so C's got to be on the line, but if this is true, if, I'm running out of real estate here, If AC plus CB equals AB, then doesn't that also tell us for sure that C has to be in between these two endpoints? Does that make sense? Right? Because it only works if that's small and that's big. Does that make sense? So it makes sense now that if C is on the line and that's true, C is between A and B. Okay? Is B between A and C? No, it's not, is it? Because if B were between A and C, if that were true, then AB plus BC would have to equal AC. Is that true? No way, right? AB is big plus BC. That's a lot more than just AC, isn't it, if we were to measure those? So that's not true, and that tells us that B is not in between A and C, but this is true. So C is between A and B. Make sense? We call that the segment addition postulate, but really all we need it for is something like this, to show that there's a point that's in between two other points. Okay? Questions on that? All right. We talked about array, right? Talked about array on Friday, and this is kind of important with array. You got to be careful. We symbolize ray AB like that, right? Just like you'd expect. But you have to be very careful here because the first letter that's written in this symbol has to be the initial point. So that's where the ray is starting, and then it's shooting out in one direction forever through the other point, right? So that's ray AB. Is that the same thing as saying, oops, hang on. Oh, I want that. Is that the same thing as saying this? Is that the same thing? It's not, is it? If I were to draw ray BA, that ray would be starting here and going in that direction, right? Be the opposite. Okay, opposite direction. So you got to be careful. You always have that first point has to be the starting point of the ray, and the second point is the target, the one that you're shooting through, right? Okay. Oh, and by the way, real quick, in Moodle, as you'd expect, you just write it as lowercase ray, and then in parentheses you put the points in order. The initial point and then the target point, right? Okay, we just talked about that. So these are, direction makes a difference. Here's ray BA, right? Starts at B and shoots through A. Opposite rays, if we have a point C that is in between A and B, then we'd say that ray CB and ray CA are opposite rays, and taken together they just form a line, right? They would form line AB. Okay, so I think I'm going to hold off on this. How much time have we have?
We have like 3 minutes.
Okay, so you're going to do some of this stuff on the assignment. There's 2 parts to the assignment. I kind of want to show this to you. Maybe this is worth just taking a quick look at. I'm going to have you do some drawings in your notebook on the assignment, stuff like this. This is what I'm looking for. If I say something like draw 3 non-collinear points, J, K, and L, does it make sense that this is how you could do it? You could show that 2 of the points are on a line and the other point is just off the line, right? Then they'd be non-collinear. That's all I need from that. If I wanted you to draw, let's say, segment KL, then you would just include this part. If I wanted you to include ray LJ, then you're going to add one more piece to that. Okay, simple stuff, but I want you to get used to doing some geometric drawing. We are going to, in the fairly near future, you're going to really like this. This is fun. there's a piece of software we can use called Geometer Sketchpad, which allows you to create geometric things within the program. And it's fun to use. I mean, not only will we do just some geometry stuff, I might even challenge you to use it to maybe design something. Design something that looks like I don't know. I mean, we'll see. But you can do some sort of creative stuff with it also. It's good for geometry because it allows you to make very precise objects. And but it's also, I think there's some real peripheral value to this. It's just like it's real similar to like a CAD program or something too. It actually introduces you a little bit to the concept of programming and to some design, some geometric design. If you have any interest in being an architect or an engineer or something along those lines, or if you have an interest in creative design and doing design work for a website or for artistic design for graphic design or something like that. This is a really good introduction to all of that stuff. So soon we'll get a little exposure to that. Okay, just more stuff this is like some things I'm going to have you do on this assignment. I'm going to skip this for now. We can come back to it later if we want to. Last issue I want to just touch on, intersections, right? So two or more geometric objects intersect if they have some points in common, right? So, for example, if two lines, I think this was sort of where we left off. If two lines intersect and they're not the same line, how many points are they going to share? One. That's it, right? Lines are straight. If they intersect, after they intersect, they're going to diverge, right? If they're not the same line, the lines have to intersect. Give me an example of what we'd say if lines don't intersect. What's one example of how lines could maybe not intersect? If the lines were parallel, for example. We'll look at another possibility soon too, but they could be parallel. If a line intersects a plane, well, there's a couple ways that could happen. The line could intersect, it could shoot through the plane, and if it does that, it's going to intersect in exactly one point. The line could also lie on the plane, right? That's an intersection of sorts. So if the green plane intersects with the pink line, well, maybe the pink line actually sits inside the green plane. And then all the points in the line are in the plane also, right? If two planes intersect, they intersect in a line if they're different planes. We looked at the example, I think, on Friday, didn't we, of like the roof meeting the front of the room? And you can visualize that. You can see that line right up there, the joint between the two walls. If you imagine that the front plane goes forever and the roof plane goes forever, then wouldn't that line also go forever, right? Could planes not intersect? Could different planes not intersect? Give me an example in the room, somebody, of two planes that would maybe never intersect. What do you think?
That wall and that wall.
Sure, we could do maybe the front wall and the back wall, right? If we continue them forever, they're always going to stay this far apart, aren't they? What's another example in the room? Floor and the ceiling. What do you suppose we call planes like that? Parallel. Yeah, parallel planes. Okay. All right, so let me just quickly, we don't have much time. I want to just kind of show you what your assignment's going to look like. Here's what you will see.
You're going to pull up assignment today?
Yeah, there's one up there. I don't think there's going to be room or time for us to get down to the lab today, but tomorrow we'll be in the lab. If you go down to the Chapter 1 resources, notice it's all set up now. So you've got the textbook, all the PDFs of the textbook are available, and then all the PowerPoints are available as we go through this. If you click on that PowerPoint right there, that's the one that we just used in class. So you can access that anytime. If you go down to the Chapter 1 practice, there's 2 assignments up there. Now notice what these are. First one is 1.2 text practice. That's what the PR stands for. Let me make this bigger so you can see this a little better. If you click on this, look what it does. It's going to be a little strange. If I attempt the quiz, what do you think that means? 1.2, number 14. It's in the textbook, exactly. So what you're going to do is you're going to pull up the PDF of the textbook, and I want to pass textbooks out also. There were some people that maybe wanted a textbook, right? Raise your hand. I'm just curious for numbers. If you would like to physically have a textbook. Okay, so if we have time, I'll do it today when I'm done here. If not, we'll get them tomorrow. So this just means, yeah, you're going to go to section 1.2, number 14, in the back of that section. If I pull up the PDF, here's what it looks like. So there's section 1.2. If I pull this up, if I just go to the end of the section, back here, see the practice and application problems? That's what we're looking at. So was that number 14, I think it was? So you would just literally go to number 14 here, and you're just deciding if that's true or false. D, E, and B are collinear. What is it? True or false? D, E, and B. Are they collinear? E is meant to be that intersection, isn't it? So it'd be true? Okay. So let's just demonstrate then. So that's true, I check, and I got it. Okay, make sense? Okay. The other thing I need to probably show you about this is if you go to the course room, you can print these out if you'd like. You don't have to. I can also just hand these out to you. Next time we're in the lab, I'll hand these out. But if you go up to the course resources, so this is stuff you'll use for the entire year, notice there are some printable handouts and resources. This is an important one, Moodle symbol and notation conventions. So what that means is, how do I write stuff in Moodle? This is just a reminder of the things we went through today. Right? If I want to write segment AB, in Moodle, I enter it as segment AB. Or later on, if that's a side of a triangle or something, I could even call it side AB. Okay? If I want to enter ray AB, like we talked about, that's how I would do it in Moodle. Angles. You're going to have to do some angle stuff. Okay, angle ABC, we would enter using the less than sign. The less than sign is our angle sign. We didn't really talk about that today. That'll be something we talk more about like on Wednesday. We'll talk more about angles, but that's something that's going to come up. Some symbols down here. We don't really have to deal with these yet. When we get to them, I'll remind you how to do this stuff. But it might be a good idea to have a printout of this, maybe just in the front of your notebook or something until you get used to it. Okay? Make sense? The other assignment is just a normal Moodle assignment. If I open this one up, oops, I want to be previewing, not opening yet. So if I open this one up, these are just kind of normal Moodle questions. So now they want to know which of the following is represented by that symbol. So which one of those objects down there goes with that symbol? Okay? And you're just going to choose one and check it and go on. There's a very short assignment, only 7 problems on this one, just to get you used to the notation. Okay? Make sense? All right. I think we're good to go. I need to take roll. You guys can relax for a few minutes here while I take roll.